There's a tiny patch of sky that looks like absolutely nothing. No bright star, no glowing nebula. Nothing your eye could ever pick out. Just black, empty space. But astronomers pointed a telescope at that nothing anyway. And it changed astronomy forever. Hidden inside that patch of darkness were thousands of galaxies, each one packed with billions of stars, stretching back across almost the entire history of the universe. Now, the James Webb Space Telescope has gone back to that exact same patch of sky, and what it found makes the original image look incomplete. The idea behind this kind of observation is almost stupidly simple, at least on paper. Point a telescope at a patch of sky with nothing obvious in it, leave the shutter open for as long as possible, and see what shows up. The longer you stare, the fainter and more distant the light you can pick up, because you're collecting more and more photons that would otherwise be too weak to register. What Hubble found in that tiny sliver of empty sky was staggering. If you held a single grain of sand at arm's length, that's roughly the size of the region we're talking about. And inside that impossibly small window, there were thousands upon thousands of entire galaxies. That tells you something wild about the universe. It's not just big, it's saturated. Point a strong enough telescope literally anywhere, and there's a good chance you'll find galaxies staring back at you. But even with all of that, Hubble had limits. It's an incredible telescope, but it was designed to observe primarily visible and near-infrared light. So put those two things together, and you get a whole population of galaxies that are either too distant, too dusty, or too faint for Hubble to fully see. To Hubble, they were basically ghosts. That's where the James Webb Space Telescope comes in. Unlike Hubble, Webb was purpose-built around infrared observation. And a few years ago, astronomers decided to point it at that exact same legendary patch of sky that Hubble had made famous, to see what Webb's infrared vision could add to the picture. To put that in perspective, some of the light captured in this new Webb image left its source around 13.4 billion years ago, when the universe was just a few % of its current age. We are, quite literally, looking at fossil light, ancient photons that have been traveling toward us since almost the very beginning of time, only now arriving at a telescope orbiting a small blue planet that didn't even exist yet when that light began its journey. Now, you might expect that with Webb's much larger mirror, 6.5 meters across compared to Hubble's 2.4 meters, the new image would simply look dramatically sharper across the board. And in some ways, it does. Webb's mirror has roughly 6 times the light collecting area of Hubble's, which means it can gather much fainter light much faster. But there's a wrinkle here that's actually pretty fascinating. Infrared light has longer wavelengths than visible light, and longer wavelengths naturally produce lower resolution for a given telescope size. In this image, galaxies that appear orange or red are picking up the longest infrared wavelengths Webb detected, and that tends to correspond to galaxies loaded with dust, heavy star formation, or an actively feeding supermassive black hole at their center, called an active galactic nucleus. Small greenish-white objects tend to be extremely distant, high redshift galaxies, whose light has been stretched so far it peaks right in Webb's mid-infrared range. And the blue and cyan galaxies, which actually make up the majority of objects in the image, are galaxies that shine brightest in the shorter near-infrared wavelengths without much of that mid-infrared boost. So this image isn't just a pretty picture, it's basically a color-coded map of cosmic distance, dust content, and galactic activity, all layered into a single frame. Why does any of this actually matter scientifically, beyond just being a beautiful image? Because deep field images like this one are essentially time machines. The nearby galaxies in the image show us relatively recent cosmic history. The faintest, reddest, most distant galaxies show us the universe in its infancy. Every new object Webb adds to this field is effectively one more data point in the long, layered story of how the messy early universe eventually turned into the organized galaxies, stars, and planets we see today, including the one we happen to be standing on. There's also something almost humbling buried in all of this. And that raises an obvious next question. If Webb can casually reveal circa 2,500 previously hidden galaxies in a patch of sky we already thought we understood better than almost any other region in the observable universe, what else is still hiding out there? How many galaxies are scattered across the rest of the sky that are too faint, too red, too dusty, or too distant for even Webb to fully capture? This single field is a tiny keyhole view of the universe, and it was already crowded beyond belief before this new data came in. It's also worth remembering that this wasn't even the first time Webb had visited this particular region. Webb had already used its NIRCam instrument to observe the Hubble Ultra Deep Field Area back in October 2022 as part of an ongoing survey program. This new MIRI-based observation builds directly on top of that earlier work, adding an entirely new layer of mid-infrared data that simply wasn't available before. So this new deep field release isn't a one-off stunt. It's part of a long-running, deliberate campaign by astronomers to squeeze every last drop of information out of one of the most studied patches of sky in the history of astronomy. So stepping back from all the numbers and instrument names for a second, what's the big takeaway here? It's this. Even in a region of sky that astronomers have already stared at harder and longer than almost anywhere else in the universe, there was still more to find. The emptiness that started this whole story back in the 2000s was already revealed to be an illusion once. Now, a more powerful telescope, tuned to a different slice of the light spectrum, has shown that even that supposedly complete picture was still missing thousands of galaxies hiding just out of reach. Every time our tools get better, the universe doesn't get simpler. It gets more crowded, more layered, and more ancient than we thought a moment before. And that's honestly one of the most exciting things about modern astronomy. We're not running out of things to discover by pointing bigger telescopes at the sky. If anything, every upgrade seems to reveal that there was always more waiting in the dark than we realized. So next time you look up at a completely blank-looking patch of night sky with nothing obviously interesting in it, remember that nothing is basically never actually nothing. It might just be thousands of galaxies quietly waiting for the next telescope powerful enough to finally see them. If you enjoyed this one, make sure you're subscribed because we've got a lot more deep space discoveries like this one coming your way. Drop a comment and let me know. If you had to point a telescope anywhere in the sky for 100 hours straight, where would you aim it? See you in the next one.